Hey everybody, it's just me, Mr. Wee. I'm just gonna go over one more sample problem from the last section, and then also hopefully I can get into 1-9, 1-10. If not, that'll probably be a separate video. Okay. All right, guys. So we left off with going from last lecture. We went from going from here. If you remember, this was the sample problem, and then we went all the way down, did multiple steps. We went to this. We finally got 7 times x plus 1 times x minus 1 times x plus 3. Okay? So that's where we went last time. We had multiple steps and we applied multiple techniques. I'm going to give you one more sample problem. You can pause the video and try it, or you can just watch me go ahead and work this out. So to kind of approach these problems that have, and I'm asking you to factor this out. Factor out this equation here into like binomials. This is a huge polynomial with 4 terms. So the first thing is, can you factor out a number out of each of these guys, like all the numbers? And I say no, because this has a 1 in front of m squared, this has a 2, this is a 50 and a 25. I can't think of one factor out. You can factor out all of them. So the next thing is, if you have 4 terms, you can also group them into things that seem to have similar factors. I think 50m and 25 have a common factor of 25. These guys have a common factor of m squared. So let's go ahead and group these guys up. M squared minus 50m minus 25. And I noticed that, or I'm sorry, I'm not going to put a parentheses over that, because that would imply that this negative is distributed to this and this. I have negative 50 and negative 25 here. So you know what? I'm going to grab negative 25 out of this. And then I'm going to keep 2m, because that's, if I take negative 25 out of 50m, then I get a positive 2m left. And negative 25 out of negative 25 is going to be plus 1. Okay. Down here, up here, I can factor out m squared. And then what I have here, I'll have a 2 and an m left together. And then over here, I'm going to have plus 1. And if you guys see here, I have a similar, similar factor. So I'm going to take the numbers in the front of these similar factors and then combine them into its own binomial. My m squared minus 25 times 2m plus 1. And then normally we would be finished, but there's something unique about one of these binomials. It's not this one, it's just 2m plus 1. This is a difference, and then both of these guys you could take the square root of. So that means I'm going to have to set it up like this. M can be squared, and the square root of 25 is 5, and that could be squared. You'd write it as this now, this next step. So again, this problem started off up here. The question was to factor this out, and then we're down at like this 4th step here. So this is going to become m plus 5 times m minus 5 times 2m plus 1, and that's the final answer. There's no further I can go. So just letting you know, the first time what I did here are these first 2 steps. These 2 steps were called factor by grouping, or you can even look at it as the first 3 steps. And then these last 2 steps, like namely here and here, that's called the difference of squares. So we applied 2 different techniques, difference of squares. So that's where we left off with in 1-8 with difference of squares. Okay, so we applied, this is called applying multiple techniques, where you do factor by grouping and you do difference of squares. Okay, so the next one is, I'm going to go ahead and go on to 1-9. So to be honest, 1-9 and 1-10, or actually, you know what? I'm going to do 1-9 and 1-10 in another video. Let's try one more. What if I gave you this problem, 18x cubed? This is going to occur in your homework, and I'm going to ask you not just to factor out and solve. What could that mean? That would mean that I have to solve this equation in such a way where this has to equal 0, and then you find out what x is. Solving means you have to solve for what x is. This isn't really that intuitive and easy, so let me kind of help you out with what you can do here. You want to set this equal to 0 eventually, okay? I know what you're thinking. Let's see, but I know what you're thinking, just like dividing each side by 18, that would work too, and then taking the cube root. But when I show you this way, it's going to give you every single possible answer because there's more than just one possible answer for this type of question. Okay, so what you're going to do is, oh, I'm sorry, and this is 50x. I'm sorry, that's 50x. So that's why you can't just divide both sides by 18 and so forth to figure this out. Okay, so let's subtract 50x from both sides, and you get 18x cubed minus 50x is equal to 0. And then let's start applying multiple techniques. So the first thing I'm going to do is I'm going to see if there's a common multiple I can grab out of this, or common factor. I can factor out an x, and I can probably factor out 2. That's probably the best common multiple or common factor I can find between 18 and 50. So let's do 2x, and you should get 9x squared minus 25, okay? And you have that equal to 0. On top of that, this is a difference of squares. You're subtracting between two numbers that could be you can take the square root of, which is this would be 3x squared minus 5 squared, okay? And this would be 2x on the outside. We keep that there, and you have to set this equal to 0 still. And then you could separate this out into two binomials now, having 3x minus 5 times 3x plus 5 is equal to 0. Now, I'm asking for multiple values of x that could give you the 0. I say outside here, 2x is not being added or subtracted anything, but what would you have to multiply x by to make this 0, thus making this whole interior in here be multiplied to 0 on the outside? This would be 2x equals 0. That's how you would set that up. You would divide both sides by 2, and then you should get that x is equal to 0. That's one solution. Another solution is to take, so you have to do each terms of x, and then figure out what x would be equal to in order to make this whole side equal to 0. So we figured out 2x. You just set that equal to 0, and then you found that x is still equal to 0. That's one solution. 3x minus 5, you're going to set that equal to 0, and to figure out what value of x will make this little guy equal to 0. You add 5 to both sides. That'd be 3x is equal to 5, and then you divide both sides by 3, and x is equal to 5 over 3. So these are two possible solutions. And then over here is you set 3x plus 5 is equal to 0. You subtract 5 from both sides this time. You have 3x is equal to negative 5, divide both sides by 3, and you get x is equal to negative 5 over 3. These are three possible solutions. Now, again, if you don't understand what that looks like, instead of using the graphing calculator, let's go ahead and use a different program to solve for this. Let's go to desmos.com. I like using this one because it's just to show you not just like how to do stuff on the calculator, but just show you like what you can graph. Like you can use a free online calculator, graphing calculator. This is a good resource, and it's a little bit. It shows you a little bit more detail, I think, and it's a little bit more intuitive than the TI-83. Uh-oh, I don't see what's going on here. Come on, desmos.com. This will make. Okay, I think it's loading up right now. It's just taking a little bit of time. Let me see if I can open up another tab, and for some reason that would load up a little bit quicker. I guess not. Okay. Go ahead and start graphing. And what we're going to do is you can graph this. You can graph either way. You can do, I would say, set this. You can graph this, or you can graph what I have at the very end. 2x times 3x minus 5 times 3x plus 5. It's the same thing. You can just graph this instead. But I'm just going to do this one because it's a little bit easier. It's the same exact thing. These two are the same exact things, just rewritten a little bit differently. One's factored out and one is not. Okay, so I'm going to write 18x to the third power minus 50. Oh, that's my phone. Oh, I guess it's really hard to tell, guys. So it's going to be a little bit tough to kind of understand what's going on, but let me just show you what was supposed to happen. Essentially, you would have a graph, and then this guy would maybe hit, like, if you zoom out of that graph, it would hit here, here, and then here, I think. Roughly what I'm trying to say is it will cross where y is equal to 0 because we're setting this equation, and all equations are like y is equal to, right? Y is equal to this equation, which equals 0. You're asking me where the x values would be. What x values would give me y equals 0? Well, whenever y is equal to 0 on this x-axis, or this x-axis here, again, the y values go up and down. If it's just flat on this x-axis, it means it's at y is equal to 0, right? The y is equal to 0. And then you would find that this would be x is equal to negative 5 over 3. This would be x is equal to 0. And then this should be x is equal to positive 5 over 3. I might be a little bit wrong in the curve going like this way. It could go the opposite way where it's going from down to up to down to up. But the thing is, I do know that it's crossing the x-axis at least at 3 points because that's what I got as a result here. It's telling me that my graph is crossing the x-axis at 3 points. Okay, so that's what that means. All right, guys, let's go ahead and make another video for 1-9, 1-10. Okay, I'm going to stop right here, so hopefully that will help you out. You guys have a great day. Bye.